So, it is also a good time for me to get out my figures. I wrote these out earlier. Alright, so, we're talking about volume. The two main categories that we have to look at here are going to be prisms and pyramids. Okay? So, for our prisms, okay, for our prisms, we're going to start with those. It's going to be a polyhedron. Polyhedron just means that it is a 3D figure with flat sides, right? So like a sphere is not a polyhedron because it's like all smooth, right? But polyhedron is just a 3D figure with flat sides. So a prism can have any shape on the bases. The sides are going to be rectangles, always, right? So here's an example of a prism. You name these by their bases. The base is the side that's not a rectangle, except you do have some options here. Like here's a cube, right? We know a cube because it's all squares, but it is a prism. The bases are squares here. Here I've got a rectangular prism. All of the sides are rectangles on this one as well. So you can have ones where they're all rectangles, and they're going to be some sort of rectangular prism. But like this would be a triangular prism. What about this one right here? So I got rectangles on the sides. What have I got on the hexagon? So it's a hexagonal prism, right? There. Here, this is a prism, and the base is a square. You could call it a square prism, or they'll probably just call it a rectangular prism, honestly. Square's still a rectangle. I don't know why they made a tiny. There's another triangular prism. This one's not a prism. It's a cylinder, but it acts like a prism, right? So we're going to kind of put these together. It acts like a prism. It's like a circular prism almost, except for it's not technically a prism because the sides are smooth instead of being rectangles. There. So now we'll also see pyramids, right? In a pyramid, like this is all triangles. This is a triangular pyramid. This would be a square pyramid because the sides are all triangles. In a pyramid, your sides are triangles. So, I'm going to put my toys up, and we're going to do something else with them here in a minute. When we get to the other stuff, so I'm going to set those aside. So here are some different examples. The volume of a prism is always the area of the base times the height. That big B is the area of the base there. And we're going to use this to build some things here. The two opposite ends here, I should put this in, are called bases. And what can be confusing about these, like for example, if I have a triangular pyramid, it's really easy to think of that being the base if it is sitting like this, where that's the bottom, right? Because base is usually the bottom of something. What gets a little confusing is when they start turning it the other way, and it's no longer the bottom. But like with this, even if we have it sitting like this, the base is still the triangles, right? It's whatever's not a rectangle, unless it's a rectangular prism for that. So some of these pictures you got to think of like sort of flipping what you've got there. Now, we've got area of bases here. And I think what I would actually like for us to do is go ahead and start working on our note card. It'll probably be better if we've got that here. Let me give everybody a note card. And you can put some examples that might be helpful, but there were not a lot of definitions or formulas or things that you had to memorize for the last unit. It was pretty much factoring and canceling. Shall we wake up? I'm gonna get. I need a squirt bottle. Be like Joey can be like a cat. Never squirt a cat with a squirt bottle like you're trying to keep them off or something.
But then I'm gonna get sick.
It's very effective. You think you'll get sick?
I'm very prone to the cold.
Huh?
I'm very prone to the cold.
Oh, it's warm enough in here. You'll be fine. You'll be fine. Okay. So, all right, we are going to put our formulas on here. It is very, very, very important that you have these formulas correct. So, and that you don't lose your note card unless you are memorizing all of these. I just feel pretty confident that y'all are not going to memorize all of these. So, it's really important that you got your note card here. Some of you show up to things without note cards, and that is going to make your life very difficult. All right, so let's look at some of the prisms that we're most likely to see here. Let's zoom in here, and I'm going to start. If it were me, I'd put Unit 4 note card up here. 5, thank you. Unit 5 here. And I would start off, it's fuzzy there, isn't it? I would start off with prisms, okay? So, prisms. We're going to start with triangular prisms. That has the fewest number of sides, so I'm going to do triangular. Prism. And for a triangular prism, my volume is going to equal, it's the area of the base times the height. And for a triangle, your base is going to be, in general, like triangle is usually 1/2 base times height. We got to be careful here though, because we also are going to have like the height of the prism here. So I don't really want to call that 1/2 base times height right here, because then I'll have two H's and I won't know which one is there. So we're going to do 1/2. I'm going to do base times, I'm going to put an A for altitude, which is like another word for height. You can have an altitude of a triangle, times the H is actually the height of the prism. Okay, now we're going to draw us a little picture here. So here's how you're going to draw a triangular prism. They're not too bad. Draw you a triangle. Okay, and then we want to draw like two little lines right here that are like at the same angle, and they need to be the same length. And then just connect right here. Sorry, it keeps losing focus, doesn't it? This new document camera's not as good as my old one. Okay, so let's label the pieces of this here. So this side right here would be the base of that triangle. The height of that triangle, or I'm sorry, not the height, let's call it altitude. The altitude would be this side right here. So it's not like a slanted side, it's how, tall that triangle is from the point down to the base right there. And then we would call this side right here the height of the prism. Okay. Another one we'll see a lot is a rectangular prism. We're pretty good with these, I think. We might could get by with not adding this one. But rectangular prism. It's still the area of the base times the height. So the area of your base is just a rectangle, which is length times width times height. So it's going to be length times width times height. I like to use sort of like a cursive L for that, just because a regular L looks like a 1. And let's draw us one of those. These are not too bad. You're going to draw yourself a rectangle. And we're going to do the same thing we did with the triangle. We're going to put us like a little line right here. And then we're going to draw 2 more little lines off the corners here. And we're just going to connect those lines. I think I drew that line right there a little too long. And so you would just have like your length right here, your width right here, and your height right here. Okay, everybody got those? There is a special type of rectangular prism that you will see that's pretty common as the cube, right? I'm not going to draw a cube, but I'm going to add this formula in here. Really, you can just use your rectangular prism formula for a cube. But in a cube, what do we know about the length of all the sides? They're the same. So sometimes you'll see for a cube, instead of doing length times width times height, you could just do the side cubed. Because it's the same thing. Length, width, and height, they're all the same. So it's going to be like, say the length is 5. It's going to be 5 times 5 times 5, which is 5 cubed. Put that up a little bit. Okay. I need everybody to look over at your neighbor's note card, make sure they've got what they are supposed to have. Like, imagine that I take up all the note cards, mix them up, and pass them back out, and you got to use somebody else's note card. Would you be angry at that person, or would you be like, oh, that's fine? And if you would be angry at them, tell them that's a sorry note card. I would be upset if Ms. Height made me use your note card. Okay? All right, now, I'm not going to draw pictures for the other prisms because they're difficult, but I am going to put their formulas here. So let's put over here other prisms. All right. We might have a trapezoidal prism. And a trapezoidal prism, your volume is going to be 1/2 altitude B1 plus B2 times the height. Same here. I'm using an A for altitude, kind of like with my triangle, because I don't want to confuse it with the height of the prism. And then, technically, this one is not a prism. But I'm going to go ahead and add it to the note card while we're working on it. It acts like a prism. So, the other one that we're going to see a lot here is a cylinder. A cylinder is not really a prism, but it acts just like a prism. What shape is your base on a cylinder? Circle, right? What's the area of a circle? Anybody remember it? Area of a circle? It has 360 degrees. That is true, but that is more for angles within the circle. Starts with pi. You're close. Nope, you're close. There's a square in it. Nope. Pi times the radius squared. So the area of a circle is pi r squared, right? And then you multiply that by the height. Let's draw us a cylinder here. They're pretty easy to draw. Draw you like an oval here. Draw 2 lines down. And then draw a curved bottom right there. And so this right here would be your radius. And here would be your height. And I'll move so it'll be not fuzzy there. I think this is going to be the majority of what we'll see. There are things like hexagonal prisms and stuff like that. I don't think we're going to really see those a lot as far as having to find the volume. Could, but I don't plan on giving you much with that. So let's go back to our notes. We got our note card. Everybody got their note card? Don't even leave it up for another second. Everybody got it? Okay, beautiful note cards. All right. Don't lose them. You need them. Unless you fully memorized them, then I don't care. But you got to know these formulas. So these are all built off of the area of the base. I didn't do a parallelogram one because although this is on here, I really haven't seen those much. The bases are the sides that are not rectangles. Except for in a rectangular prism where all sides are rectangles. Okay, so a lot of times it's just one of the big things is making sure you're using the right formula. So you've got to know when you have a prism and when you don't. So if I look at all of my pictures that I've got over here, labeled A through F, can you guys tell me, it says which figures are prisms and what type of base do they have? So actually I'd like to throw out the ones that are not prisms first. So who can tell me one that they think is not a prism? C? C is not a prism. It's also not a pyramid. That's, I think that's a tetrahedron's the triangles. It's like a decahedron, dodecahedron, I don't know. We don't really have to know. We just know it's not one of the ones we can find the volume of, right? But it is not a prism. Okay? Which other ones? What do you think, Cannon? F is not a prism. What is it? These are all polyhedrons because polyhedron just means you've got flat sides, and it's a 3D figure. So that one where all the sides are triangles except for the base, that's going to make it a pyramid. It's a type of pyramid. So we'll look at pyramids again here in a minute. There's one more. A. What have we got for A? That's a pyramid also, right? That's a triangular pyramid for that one. So the ones that I have left are prisms. What type of prism do I have for B? Rectangular. Okay. What about D? That's a trapezoidal. Prism. Okay, and what about E? Triangular prism. So whenever we're looking for that, we're looking for what are my sides that are not a rectangle? Obviously in the first one, they're all rectangles, so it's just a rectangular prism. Those are usually pretty easy to identify because there's boxes, right? In the trapezoidal prism, it's not always the bottom, it's the side that's not rectangles, right? This side and the back, those are your trapezoids. Here, it's not the bottom, it's the side that's not rectangle, so it's like a triangle on the side there. All right, so let's do a few problems. One, we should all get number one right. This is a rectangular prism. What was my formula on my note card for rectangular prism? Length times width times height. So for this one, all I've got to do is 7 times 5 times 3 here, which is going to give me 105. Is that right? Okay. Now, one thing I want us to be in a good habit of is giving units. So this is centimeters cubed, cubic centimeters there. 2 is a lot harder because 2 has a lot of sides that we actually don't need to use. It's got everything we need, but it's got a lot of sides we actually don't need to use. First, let's identify it. What are we looking at here? Triangular prism. And Fernando, on the sheet there, what is our formula for a triangular prism? Not just 1/2 base times height. Look on your note card. Okay. So this first part, 1/2 base times altitude, that comes from the base. This is your area of the base of the picture. The base is the triangle, right? Now this can be a little tricky. We're talking about this triangle right here. Okay? The base and the altitude have to be perpendicular to each other. Okay? So, what is the altitude of this triangle? I think I heard it. It's going to be the 1.5 right here. This is your altitude, which means it's got to be perpendicular, right angle. This side right here is your base. What is that? That is 5. It's not really given like in the triangle, but it has to be the same as this side up here above it, right? So we've got 5. So our volume is going to be 1/2 times the base, which is 5, times the altitude, which is 1.5, and then I need the height. It's going to be the 4. It's coming from this 4 over here on this side. It's the part that's not in the base, right? That is your height right there. So that will be 4. Okay. Whatever your height is of your prism is not in your base. Think of, in this case, your triangle is on the bottom, right? Think of it as like how high it is sitting up off of the table, right? There. So, if we just type that in, 1/2 times 5 times 1.5 times 4 is going to give you 15. I'm just typing that into the calculator. You could use Desmos there. What are our units here? Just yards? Cubed. Yeah, you can say cubic yards or yards cubed. Make any time you do volume, your units are cubed for that. Okay, questions? All right. Okay, let's go to a cylinder. A cylinder is really similar, even though it is not technically a prism, right? A cylinder is a three-dimensional shape consisting of 2 parallel circular bases joined by a curved surface. And we've got our volume here. We went ahead and added that to our note card so we don't have to put that in there. And we are supposed to find the volume of this. So volume here is pi, which is a number which you just type into Desmos or the calculator, either one. And you don't have to put 3.14. Just type, like in Desmos, if you type pi, it types a pi for you. Or it's in the menu if you want to use it there. But pi is what I usually do. Pi times, what's the radius of this? It is 8 squared. What's the height? 15. So, I'm going to pull up Desmos just so I'm using what you guys use most of the time. Okay, so volume, you don't have to be pi times 8 squared times 15. 3015.929. 3015.929. And that would be, in this case, centimeters cubed. These problems range from like really easy, like length times width times height, to a little trickier because it's hard to tell what is what for those. Okay. I've got a video demonstration linked here, but we're gonna do like an act. I'm gonna show you, or I'm gonna actually do this here. I need everybody right now to guess for me. I've got a cylinder, a cone, and a cylinder. Okay, the cone and the cylinder have the same size base, right? The bases of these are the same size. They also have the same height. Okay? So my question to you is, if I fill this cone up with water and I pour it into the cylinder, how many times am I going to have to fill up this cone to fill up the cylinder? Is it going to be, are they the same volume? Is it going to be 1? Is it going to be 2? Is it going to be 3? Is it going to be somewhere in between? I need everybody's guess written down. Don't say it out loud. You may already know. If you know, that's fine. It's great. But have you seen it done before? Okay. So guess. Write it down. Is it 1? Is it 2? Is it 3? Is it 4? Is it somewhere in between? Is it like 2.5? Is it, pi? What is it? Okay? Write down your guess on this slide right here. Everybody's guess written down. I'm coming around to see what your guess is. So I need to see something written down. Everybody's guessing. Make your guess. Come back closer so you can see. Get your guess.
You caught me something weird. I thought I heard you call me
Yes,
something weird.
yes. All right.
Oh, I was right. It was weird.
Okay, write that guess down. I need it recorded. Okay. Okay. All right. Okay. All right. So let's see. All right. I see some correct guesses. Okay. All right. So do this without making a mess. All right. Okay. Here is one. So all of you that guessed 1 are out. And if you guess less than 2, I think you're out. So that doesn't look like it's half full yet. I don't know, maybe. Alright. Oh gosh, I just spilled a little bit. Okay. If we're a little under, that might be why. Okay. There's 2. So it's more than 2. More than 2. Alright, let's see. Okay. I'm not picking that up because it is right up to the top. 3. 3 is correct. So if you guess 3, you're right. For that. If you guess anything else, it's not correct. So you can put the right answer there if you want. I think this is like, I can remember a teacher doing this somewhere along the way, like when I was in high school, and I did not think it was 3. I think it's misleading. I think it looks like it's less than 3 to me. Like it looks like it's maybe 2. But hold about half, but it doesn't. There. I also think, like, if you're ever, like, buying something that comes in a cone, that it's a little bit of a rip-off, sort of. Like, some things come in, like, cone sort of shaped packages. Like, sometimes there'll be, like, bags that are sort of cone shaped. I know that, like, there's this popcorn stuff that used to be at Ingles that I really liked, but it was like a cone shaped bag. There was hardly anything in it. It would be gone really quick. I think there's some other things that they'll sell, like in sort of like a cone shaped, and it's not as, you're not getting as much as you think that you would sometimes. So look at our formula for a cone. Okay? You may have already looked at the formula. That might have been how you got your correct guess. What is our volume for a cone? It's just 1/3 of our cylinder volume, right? 1/3 of our cylinder volume here, because it takes 3 cones to fill up the cylinder, right? So it's just 1/3 of our cylinder volume, and we will add that to our note card here in a second when we get to the pyramids. So we'll add it to our note card, but let's just go ahead and do this problem first. A cone is a 3-dimensional shape that narrows smoothly from a flat circular base to a point called the vertex or apex. You may hear it called either one of those points. So, when we find the volume of a cone here for this problem, we're going to have 1/3 times pi. What's my radius? 5. So 1/3 pi r squared times the height. What do I use for the height here? It's going to be 12, not 13. 13 is what you call the slant height. If we were doing surface area, we would have to do that, but we are not. So it's got to be, that height has to be like that perpendicular height, like how high it's sitting off the table. There. So if we type this one in, we will have 1/3 pi times 5 squared times 12. And so 314.159 and that would be inches cubed here. Okay, we are about out of time, so let's do this. Let's add our cone formula to our note card, and then we're going to have to quit for today. I'm going to put mine on the back here. So our cone is going to be 1/3 pi times the radius squared times the height. And if you want to draw a cone, just draw a triangle with a curvy side here and put your little dotted part right there. This part is your radius, and this part right here is your height. So make sure you've got that on your note card, and once you get that, you are welcome to pack up. I'll just break my pencil.